Howdy, folks. How's everybody doing today? Sorry I'm missing you there in person. It's been a rough week, so um, I'm working on getting better still. The cold is here now, and I'm just coughing up a storm, so I don't know how long my voice will last. It's already cracking a little bit, but I'll do what I can here. Missing a whole week of class is rough, so I think we can at least get through some of the object-oriented stuff. I want to talk about the project as well, so you can get going on that, and then we should be able to go from there. So thanks for getting your tax forms estimators in the Forbes project version. Looks like we got most of those here. Now let me give that a quick refresh, see what our count is up to. Yeah, 40 of them in. That's almost everybody, so fantastic. Just a quick little practice using forms, because we're going to be using them here on out, because they're much more interesting. I think using a form is much more fun than just having everything showing, in the console. So it should be okay there. So I got to get my blanket. My basement is rather cold in the winter, so I have a USB powered heated blanket. This thing is amazing. So I'm just gonna huddle into this, and should be okay. All right, so moving on then, we're getting into the object-oriented piece of our C# programming. We got about 3 weeks for this. We'll see how long it takes us. We might be able to get started on some of the advanced stuff come February. We'll see how far it goes, and you just kind of take it from there, because this is fun stuff as well. So I want to make sure we have enough time for the advanced topics. But again, we'll be using forms here on out because it'll make our programs more fun to do, I think, and that's sort of the goal. So, all right, so let me pull up Visual Studio here, and I want to start with the forms project. So we had most of it kind of already done here, at least a shell of it, I think, that we were working on from week 2. So I'll just go finish that, add in the rest of the features here, and then we'll get into the new stuff. So I kind of played around with a little bit of this. So again, my form and design view is where I can start dragging and dropping all my tools and options and buttons and things. Then all of our code goes into the Form 1 CS, so all the event handling. What do we do when we start clicking buttons and things change and whatever happens here? So for our radio buttons, right, we had 3. I don't think we need all 3 of them here, so I'm going to change those. And then if I want to reference these later, I need to make sure I give them names here. So let's call this the single button, radio button, and then we'll call this one the married radio button here. Radio button. And then one of these we could default to checked if we wanted. So when you come down here, we can say, hey, this one probably, let's say, starts as checked here. And then we can, rename our group box here if we want. So the display on this, we don't want it to be group box. This will be filing status or something like that. And you can go and pick single or married. Oh, we should change our text here. So this is single, and this is married. Is that 2 R's? I think are there 2 R's? I don't remember. We can enter some deductions. We got some buttons here. We can set up some of these labels. I think we're going to change. Yeah, this is our deductions label, so we can take the text out. Again, pretty was not the goal here. Pretty is nice. Pretty is good. I don't mean to discount any of that, but in terms of what we're going to focus on, we're definitely looking for function over form, and assuming you can pick up the form stuff later, or really it's a whole other specialty of human-computer interaction or user experience, that sort of thing, when you start dealing with what does it actually look like and how well does it work for you here. So, and then we kind of need a place to show some output as well. So if we just give it a run, excuse me. Yeah, the cold beds make me loopy too. I apologize. Loopier than usual, which is, that's fun. Hector, my friend, thank you so much for donating to the Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. We are close to hitting the $500 mark, if I recall now, because Switch will pay out every like $50, and I can go and donate it to the scholarship fund. So that's fantastic. Thank you so much for your support. Anyway, so we enter some incomes, right? So we'll figure it out, and then okay, but our box is kind of in the way, so we'll go kind of shrink that down a little. Forgot we had another label over there. Just make that look a little nicer as we go. See what's happening, and we can add some more incomes if we want. Doesn't really matter how many we add, and it should just total all of them for me here. We see we keep totaling, and then we can enter some deductions. And again, I don't think we added any logic here yet, so let's take a look. So let's take a look at the deduct me event handler. Okay, we didn't do anything yet, so we need a place to store that information. So we have total deductions, right? We should set it to 0, great. And then we're going to take that and we'll add my converting again here from our, instead of the name text box, we want the deductions text box here. Cool. We should probably rename this name text box, because that's not a good name for this one here. So not super important here, but this will be our income text box here. So if I rename it, it's actually going to go and change it everywhere else in the code, because the design view is like hooked into this. Hey Jello, I'm sorry if you're having trouble with Twitch. We do get what we pay for. I don't pay anything for Twitch, so I apologize if it's a little bit buggy. I think it's okay. I have the Twitch inspector set up. Usually it tells me if there's any downtime. Yeah, I think the stream's been solid, so it might just be on your side. So at least in the recording, you'll be able to see it okay. Yeah, so if you do run into issues, let me know. If you folks really want to switch over to Zoom, I'm open to the idea. I just, generally staring at a bunch of black boxes is annoying, and then trying to upload it to YouTube is a whole bunch of extra steps for me. So, oh, that's weird. Okay, yeah. If you got trouble, let me know. And hopefully the recording, at least we can go back there and we'll make do the best we can. Sorry for the issues. All right, so we renamed it here, and it renamed it everywhere for us, right? That same kind of idea. When you right click, you can go to rename, and it will rename it everywhere for you inside of code, which is the right way. We want to use the tools to do this. So that should work out pretty well. So the same idea, we want to then go and set that to empty to say, okay, we've marked that deduction down. I've got it here. And then we'll go change, instead of our income text box, we'll take the deductions text box, set it to blank. And then we'll take, instead of, that's our label here, we want our deduction label. And then we'll set the text to total deductions, right? And then that is our total deductions amount here. So similar approach here for all of these. And then, yeah, we should change that label. That's going to be sad here. Where is that? So if you can't find it, remember you got your drop down here. You can go find where that one label is here. Because if you take the text out, it's hard to find here. So let's call this one our income label, just to make life a little easier for us. And then now it's called income label. So I'm trying to clean up some of this stuff. The other labels, like I never name these things because we never reference them in code. So because it's called label 1 and label 2, I don't really care. It is a little bit awkward when you're looking for stuff in your properties list here that you've got some generic ones. So if you want to give them a name, go for it. Give them a name. It's not going to hurt anything. But we just, if we don't need to, generally I try and avoid it. All right, so we should be able to get deductions going here. As we start, adding in some here, we'll deduct and then add in some other numbers, and it should total up for us, and life is good. Okay, so that's adding okay. Not too much trouble for us. So we can get income, we can get deductions. Fantastic. Now the actual calculation piece then, right, will be showing it on text somewhere. So we probably want to clean this up a little bit. So I'm going to try and drag these ones over here, and then maybe we'll call this, instead of click me, maybe we'll change that to say this can be add income, and then we'll have our deductions. I'll just drag these over here. I did a shift click, sorry. If you click on more than one thing, you can shift click to kind of group them together, so I can drag them all at once. If you want to make those line up, it's probably a prettier idea here. I'm not too concerned one way or the other. And then I'll go find my income label, and we'll drag that up there, and then we'll find our deduction label, and we'll drag this one over here and be, somewhere around here, and then we can move our filing status somewhere over here. All right, all of this, so I have a place to put this. Yeah, control click. Yeah, I think there was, I'm trying to remember, usually Shift does multiple items at once. I don't remember. All right, so then we need a place to put it. Now we could do it all in one more label if we want and add our own new lines. That's perfectly fine. Or we could take a look at our toolbox and see there's also a couple other options here. Instead of text box, we want, I think it's all my items here. It's like I want a whole area. Oh man, it's not a rich text box. Is it like a area text label? That's all right. I'll just use a label for now. I'm not remembering off the top of my head what it is here. And then we'll call this our tax info label. Sure. We can go set the text for that. And really, we kind of want this to update all the time. It should work out pretty well. Yeah, contact me whatever way you prefer. Discord, email, text message. Any of that's perfectly fine. Whatever you like. I'm pretty open to contact info maestro. So if I'm going to do this anytime, right, it could be its own method. It doesn't have to be an event handler method. We can just write another method then that calculates deductions. So we can just make a private void, calculate tax. Sure, why not? And then from here, we can go and do the stuff we did in our console-based application. So let me open up my GitHub for the class 297, and we'll go steal that. So that was our tax estimator program. So basically this, right? So we need a couple of these constants. Let's go grab some of these here. We can go add these in. And then we're going to do another set of constants here. So these are single here. So all of these will be for single. Why is that still open? Close that. No, I didn't want that there. Single, and then we'll do another set of these brackets for married. And these will be different, right? Because we have different values. So that should be 25, 900, I think. We can go look that up here in a second. And we'll add in these married ones. So we'll use whichever set of brackets is based on whichever checkbox is checked, or radio button is checked here, right? Let's go take a look at that MoneyChimp site, MoneyChimp tax bracket. And then we'll flip to the married brackets here and see if we can't go edit some of these values. All right, this is getting a little bit cramped. That's okay. Oh, here. Pull it over a little bit. Are we getting closer? Maybe. Unpin one of these. Hey, thanks for following along. All right, here we go. So this will be 20, 550, and this will be 83, 550, and this will be 178, 150, and this will be 340, 100, and I missed one somewhere, didn't I? Shoot. 0, 20, 83, 178, 340. Oh, there we go. 4, 431, 900, and then 647, 850. Sure, because these numbers make sense, right? They are not double at all, which is just weird, but that's okay. That's another story. All right, so I've got those. Awesome. So we've got the brackets picked. Then, I might as well, because we're citing our source here. We're going to follow some good habits. Say, hey, I got it from here. Right? That's my source. So I found it online. I'm going to cite my source. We got it in here. So calculating taxes then, again, works out pretty much the same way. We need the total deductions first, and then we'll go figure out our taxes owed. And then instead of writing all of this, we'll put it all in a label, but we can copy paste it for now and see how close we get. So we don't have the get tax function. We need that one as well. So our get taxes at bracket. We can go add that one in. Okay, get taxes at bracket. We got that. We got taxes owed. So we have two different options for this, right? We need to look at if we were single or married. So we can check and say, hey, if the single radio button dot checked, right? If it's checked, then we take the single, standard deduction single, and great, we can set that. Otherwise, right, if it's not checked, it's got to be the other one here. We can check for the married. Married. And set it to married if we're less than that. If you use the same code in your form, I expected everyone to use it. Citing it's obviously better, but for this one, like I said, feel free. I'm pretty sure I mentioned that in class, so no big worries there. But you want to be in the habit of, if you've got something that's not yours, cite your source. That's just how it works. This is academia, right? You give credit to your sources because that's what we do. And, even in the real world, as a professional developer, it's good to say where you got something from, so you can go back to it, right? Like, it's helpful to have sources for that reason. You can go back and see, oh, hey, where did this come from? And then you can go find that again. So it's pretty useful. Okay, so we don't need to do total deductions, right? That's already showing in our label. No worries here. We'll get our adjusted gross income. We don't need to show what that is either. We could, I guess, if we wanted. Maybe we'll do that at the top of our label. So I'm going to take that label here. So we'll take our tax label or some tax info label, and we can set text. We'll set the text equal to this to start, and then we'll calculate all the taxes owed. Now, again, we need to check for single versus married here. So, all right, we can do that. So we can say, hey, if my it's this one up here, right? If this one is checked, and we'll do all these. Otherwise, we'll do all the ones at married level. So this will be, we'll just throw in a bunch of singles here, right? And then this is just a bunch of fun copy paste, throw in single everywhere. Single, single, single. And if it's not single, then we'll have married, right? We throw married in everywhere here. Throw it in on this side. And if you put these in a list and loop through it, that's fine too. I don't think this is too bad here. Oh, now it doesn't like these variables. So if we declare the variable inside a set of braces, right, we can't use it outside. So let's go and declare all of these first, and then we'll go set all of them after to one or the other. Oops. Go take all those out, take all these out. Sure, and then we can just blank all these. Shift Control here? No. I want to go to the end. Oh, Shift End. That's obnoxious. Shift End. Okay, Shift End. Shift End. Shift End. Shift End. Shift End. All right, there we go. We got rid of all that. Again, I have to scroll a little bit left and right, but I'm zoomed in kind of far, so on your screen you probably don't have to do that, and you won't feel too bad about it here. So we've got all that info. Now we don't want to write line. We want to take our label text here, and what we want to do is we want to add to it. So you can concatenate text, right? You can smush text into text here. So instead of saying equals, we'll say plus equals, and then I'm going to put in my own new line character. Right? The \n is that new line character. I can throw that in myself here. So I'm going to do all of these here with these, and then we'll go and throw in our new lines here and get rid of some of those parentheses. Everything else should be about the same here, right? Just get rid of some of these. Oh, and then add in our new lines. Yep. Great. And then instead of writing line here, right, we'll do that one, and this one, and that one. And don't forget our new lines. So just a little bit of editing here, right? Not too bad to make it from console output to setting it to a label and just throwing it on the string here. Alt and click drag to get a rectangular selection. Yeah, if you're gonna grab a bunch of those, Alt. There we go. Yeah, to edit multiple lines. Thank you. That's a handy shortcut. All right, so then we don't really care which one is checked when we do these radio buttons. It doesn't really matter, right? We just don't do any of that. So we use the radio button, but if it's checked or not, I guess the only thing we'd want to do then is when one of those happens, we can go and call our calculate tax method. So if you check a radio button, we'll calculate tax. If you click add a deduction, we'll calculate tax. If you add an income here, we'll calculate tax. Right? Pretty much whatever we're doing here, we'll go and calculate tax. We could even do it at the start, right? And I think it'll work with zeros. Is that going to fail? So we can, like, anytime you add something here, we'll do it. Let's see if it works for us here. I think I hit run. Oh, did I build errors? Nope. Okay, cool. Yep. So, negative. Probably shouldn't have negative. Yeah, we get not a number. Okay, so if it's 0, probably we can clean up a little bit of that here. So let's take a look. So adjusted gross income, and then hey, if my adjusted gross income is less than 0, let's say adjusted gross income equals 0. Just put that back to 0. And then with these ones, if I'm not even too worried here. It would be nice to do that sort of thing, but yeah. So you can, like, take a string and add to another string, that concatenate strings together. So should work. All right. So we need not a numbers. That's probably okay. So cool. So we'll add some income here. So let's add 10,000 of income. Still no taxes, right? Because of our adjusted gross income. Still technically 0 here. So let's add some more income. Now we start having some taxes here, right? And if we change brackets, it should change for us here, right? Because our values are different. Uh-oh, it's not changed once, but not twice. Why is it not changing back here? I think it's updating, right? Can we change our bracket? If one is checked or the other is checked. Gross income. Let's see. Oh, so we have total deductions that we're actually changing here based on the standard deduction. So we probably don't want to change their actual deduction amount, right? That's interesting. So this is because we want to keep the total deductions value based on what they've entered. That's why that one got messed up here, because it's giving me the other deduction because I changed the other radio button. That is interesting. So we probably just need another variable then for it. So how about we add another double for, is that a double? Or are we doing ints? I think we're doing ints here. So an int for claimed deductions equals total deductions. And then let's use this one here so that we always use the same total deductions without changing that. So then we got to make sure we're doing minus. We use that anywhere else? Okay, we didn't use total deductions anywhere else. All right, let's give that a shot. Again, not too much to it, but there's a couple things here. So add some income. Great. So we pay taxes singled. When we go to married, we don't. Back to single, we do. Married, we don't. Single, we do. Married, we don't. Okay, cool. So if we add in some of our own deductions, again, we can see what we have here. So that's okay, Fluffy. It's not really the end of the world. It was just some practice using the radio buttons and trying to add a little bit more to it here. So cool. And then, again, if you had another button that made this display, that's perfectly fine. It doesn't have to trigger off of everything. This is just totally an option for when we are building user interfaces. We get to say how I want it to act. Right? It's totally up to us. That's a design decision on, it will change only when I click this button, or it'll change all the time, or all the buttons, or anything like that. So, all right, very cool. Yeah, so we can go through and set it kind of however we want here, but that's sort of the gist of this one here for our form version of this. And now I'd like to imagine this one is much nicer than the console-based application, right? This one just kind of, it's a little easier to interact with, to see what's happening. Console-based stuff is a little rough for people, and then now you have the ability to go back and add more deductions and see how that is going to impact your estimated taxes and that sort of stuff. So got lots of fun options there. So let me go ahead and I'll commit this one here to GitHub. So it'll be out on the GitHub repo for the class in a second. 297. There we go. Nope, not the 2019 version. Oh my goodness. There we go. So this is tax calculator in forms. Sure. So there's no loop, Jaburi. We just let them, anytime they want to click the button for add deduction, they could go in, or add more income, they could just go add more income. Oh, we called it click me button. That's right. We never renamed that one. It's a small pain to rename that stuff. So I guess we could probably do it here. If we rename, let's call this the add income button click. I think that'll be safe enough for us. Yeah, okay, that worked. So anytime you click add income, we'll just take whatever values here. We didn't need to ask them because as soon as they stop clicking the button, we can move on to something else, right? It's not a top-down based approach anymore where we run from the top to the bottom of our code. The UI just exists and has to respond to the user. So we just say, okay, if you click the button, we'll add the income. Fantastic. At some point, if you want to say, hey, you can no longer add more incomes, that's a design decision, and we could turn off the button, that sort of thing. So you have options as well with the designer, which is really fun. You can disable the button or make the button not visible anymore, or that sort of thing. So if you only wanted to let them enter one time, sure, that's an option. So on our add button here, you can take the add income button. Oh my goodness, we never changed the name of the button, did we? What is the name of this in properties? It is, it's still the click me button. That's why. Okay, so this is the add income button. Add income button. So then in my form, I can take my add income button, and there's an enable property. We can say, hey, it's false. You are no longer enabled, so you can't be clicked anymore. So once I click it once, hey, let's add some income here, right? Now the button's turned off, grayed out, you can't click it. So you got some fun options for what you want to do with your UI. We didn't get a chance to get into necessarily everything here, and I wasn't looking for everything. Just some basics to get us started. So we'll get more practice with forms, and we'll use them and then do some more of this fun stuff as we go and start doing our projects. So should work out pretty well. All right, other questions, thoughts, or concerns? I'm going to leave this off here. Just, because I don't actually want that. So disable buttons too. I'll give that a push. All right, I think I got the mute button there. Hopefully I didn't blow out your ears. Sorry. All right. Anywhere. So there's some conventions around where you put your functions or your methods. I honestly don't really care. Generally, you put the public stuff at the top, the private stuff at the bottom. Some people like the variables at the top. Some people like the variables at the bottom. I don't really care. And there's tools that will go and format your code for those sort of convention things for you, if anyone really does care. There's some really cool tools out there for stuff like that. So it's not really worth our time to mess with. So yeah, and C# is smart enough; it'll go find it anywhere you put it here. And if you want to go and quick jump around, I don't know how much you've played in Visual Studio, but in my class here, right, I can go and find all the different things in my class here, right? I can see my methods, I can see my attributes, these sorts of things, and we can go and have some fun with them, which is just kind of cool. So you can just kind of jump around. Yeah, Fluffy, just however you like to read it. It's up to you. So again, when you get out into the industry, whoever signs your paycheck generally will have some sort of convention, and go for it. You follow that convention, because when everyone does the same thing, it makes life easier for everyone. So and that's sort of why organizations have conventions, and we have rules around how we name things, and just if everyone does the same thing, it makes it easier for us. Straw hat static, it means the same thing as it does in C++ or in Java, depending on what your previous language was. It is defined once at the class level. So it belongs to the class instead of the instance. So where these are not static methods, they belong to the instance of form, because they have access to these instance values here as well. So technically, I could have this form open 5 different times, and each one could have its own set of income and own set of deductions, right? Versus you would just have like one existing shared among all instances of it. So with forms, it's not quite as interesting here, but we're going to start talking about that when we get into classes here in just a little bit, and start looking at how we use our own classes in C# and do those sorts of things. So, all right, awesome. Let me start a new project here then. And I'll make another forms app, because forms are fun here. Make a forms app. I want this one in the course repository to make sure that GitHub can track it here, and it will go to the public one that you folks can all see. This is week 3 classes. Or object-oriented programming. It's object-oriented programming. Cool. Go next and create. Ooh, my voice is not holding up there all that well. All right, so we'll take a look. I want to pin my Solution Explorer and my properties again because I like having those open. It's make me happy. All right, so an empty form, not a whole lot of anything interesting happening here yet, but now we can start building some classes and using those classes in our form. So I'm actually going to go back and reference our book here a little bit, make sure we're kind of staying on track. So looking at object-oriented programming here. Now, you should be familiar with classes, which are essentially our blueprint for how we create instances of objects. Right? The class defines, here's all the properties, here's all the methods or the public functions, things that you can do. You can have your private functions if you don't want them publicly accessible. That's great. So it follows this idea of object-oriented programming. So we want to encapsulate all the details together into a nice little package. Generally, our classes are nouns. That's just a general rule here. When you're trying to define a solution and figure out how I want to solve a problem, anything that's a noun could be a class. Doesn't mean it has to be, but that's a pretty good starting point. And then the things that those nouns do, their verbs, tend to be our methods. Right? How do we interact with those? So if I go and, let's just make a really basic one. I'm going to go to my project here. I'm going to right click and say, hey, I want to add a new item and I want to add a new class here. And I'm going to call this, how about cup? Because I'm thinking about coffee right now. So I have a class for cup. So you have a couple different access modifiers. Internal's a little bit funky here. Usually public is easier. Internal's open to the entire package, I believe. I always have to look that up because I can never remember all the fine details. But I want to have a public class for cup here. And then the things about my cup, attributes of cup, right, become my instance variables. So what do we know about cup? Well, cup has a string for, how about the color? Cup has and that's right, we want a public string for color, and we want a public string, string for contents, sure. And then how about a public int for volume in milliliters? Milliliters? There are two of them there? Something like that? Sure. Color, contents, volume, and milliliters. I think that's probably spelled right. So anytime you're dealing with measurements, right, you should put what you're measuring in the name because it just makes life easier for everyone. So if you don't just say volume, because everyone measures things differently when it comes to volume. Like not everyone uses the metric system like we're supposed to because our American imperial system is just awful. And then people get confused and they're like, hey, I bought a 2-ounce container. And sometimes ounces is weight and sometimes ounces is volume. And I just don't understand. It hurts my head, to be honest. So, but sure, that's fine. And then you're probably thinking, oops, Eric, we probably don't want these to be public, right? Because our good encapsulation principles say we should hide away the private details and you can work with it abstractly through abstraction and you get public methods. Well, that's true. So we can say, hey, these are private values here, private values, private values. And then what we'll do is we'll make public functions to get and set them. So I can have a public void get color, which returns color. Right? These are all the really boring things to write here. And a public, a string for get color, and a public void set color, right? Given a string for color. Look at that, it's like suggesting this for me. And it says this color equals color. I love this. Yeah, I've been working on switching myself over to the Celsius system because Fahrenheit is also awful and just not used very many places. And everyone else around the world uses Celsius. So and it makes so much more sense, right? Water freezes at 0, boils at 100. Why there's reasons in the Fahrenheit system, but why does water freeze at 32 degrees and boil at 212 degrees? And why do I have these numbers in my head? It's awful. So straw hat, we're going to talk about that in just a minute. There's ways to do this and good practices that we're going to talk about, and a lot of shortcuts when it comes to C# because C# is just fantastic. So we can have these methods. This is fantastic. And then over my form, again, let's drag in a toolbox or grab our button here. And then I don't even need to change a whole lot of things here, but I'll grab a label. Sure. And that's label 1. Sure. So when you click the button, we'll say, okay, well, what do I want to do? Well, I want to make a cup. So cup equals a new cup. In C# land, we always use the new syntax. It doesn't mean we get pointers. Technically, every variable is a pointer already. We don't have the hassle of dealing with some things are pointers to objects and some things are actual objects and that sort of nonsense behind the scenes. It's all managed for us. So when a variable goes out of scope, the garbage collector in the .NET framework or .NET runtime, that's right, because it's not the framework anymore, the .NET runtime will clear that up for us. We don't have to manually delete stuff, which is fantastic. So everything is instantiated with the new syntax. There is no just cup, right? You just can't. It won't make an object. You can declare one and say, hey, I want a cup of type cup. Nothing gets loaded into memory until you instantiate. You can do it in 2 lines. Almost everyone does it in 1 line. This is just what you do here, but you can do the 2-line method if you like here. This declares, this instantiates, this will create it in memory. So this will go through and run the cup constructor. Now, we don't have a cup constructor right now, which is bad. We should have a cup constructor. So there isn't, my goodness. Why am I not getting my, that's fine. So we want a, oh goodness, not that key. Public cup, so the constructor, right? Name of the method matches the name of the class. There is no return type. Same thing, these are our constructors here. So primitives, yes, well, technically they're not references. It's a little bit messy when we get to primitives. So really that's just our ints and our doubles and our floats and our chars. String looks like a primitive, but it's not a primitive. I don't know why they give you the shortcut, but like when I hover over it, it says, hey, it actually is a system.S string, the class string. So those are reference types. But so for our constructor, right, the constructor's job is to give values to attributes. Literally its job. It should make sure all of your attributes have values. That's why we have constructors, because nulls are bad, right? We don't like nulls. Nulls make us sad and crash programs, right? Nulls are the bane of our existence because our programs will crash with those null reference exceptions. We hate nulls. So I'm going to avoid that. So my constructor here with no arguments, or a default constructor, will say, hey, color equals string empty, sure. And contents equals that, string empty, I like it. And volume in milliliters is 0. That is fantastic. It's just suggesting code for me. Thank you, Visual Studio. I love it. Okay, so we have some options. I will take some defaults here. The other thing we can do is we can make a parameterized constructor or constructor with parameters, right? That takes string for color, string for contents. Look at that. Int for volume in milliliters. I love it. Write more code for me, tool. This is awesome. And yeah, this color is this color, this contents is contents, and this dot volume in milliliters is volume in milliliters. So this again refers to the current instance. So a lot of times in C# you had this pointer. We don't have the pointer notation. It's just this dot. So everything is the dot notation when we deal with classes. So this dot is the color attribute here of the class level attribute. The color here is the argument color. Now, if you're not colorblind, speaking of color, you'll notice this is kind of light blue and this one is white. So you get some of those visual cues saying, okay, here's what the values are. Now, having 2 different constructors, perfectly fine. We can work with this if we want. The other option you get, instead of having one that has no arguments, is you can give default values to your parameters and methods. So I can say, hey, this is going to default to 0. If you don't give me a value for it, I'll assume it's 0. This will default to string empty, and this will default to string empty. String.empty. Is it not? It does not like that? Uh-oh. Must be that's not a constant, really? Okay, sure. I guess we can't use empty there. Why not? That's fine. It's essentially the same thing. So this dot is the current instance of cup. So I can make 5 different cups here. I can have cup, cup 2, the new cup, and this one will be, I don't know, this will be wood, colored, content is coffee, and the volume of milliliters, I think it's probably like 250 milliliters or so, right? Cup and cup 2 are 2 different cups in memory. So when this constructor runs, cup 2 is this. That's the current instance that we're talking about. So cup 2's color, cup 2's contents, and cup 2's volume in milliliters, because these are instance attributes or class level attributes. Right? Instance, they belong to each instance of cup. So I can have a bunch of different cups in memory, each with its own set of these attributes. Yeah, this is the same as self in Python. Yep. Yeah, they use this in C++ and C# and Java. They use self in Python. I don't know why the fine folks at Python didn't use this, but go for it. I didn't write the language. Yes, yeah. So everything is an object. Ecor or icopore. Yeah, we have a nice little inheritance setup here. So depending on what things should be set in your class, sort of depends on whether or not we have the arguments here. It really depends on what your class is. So, if you never are changing color, it's not a very useful attribute. I don't know why you'd have it anyway. So, most of our attributes will probably change or be changeable based on what we want to set it to. So, I like having arguments for things, and that just works out pretty well. So anyway, we can get color, we can set color, these sorts of things. Now, with color and contents, we really don't have any sort of contents. There's no bounds checking for these sorts of things, right? It's just, you tell me what it is, and that's what it is. Right? I don't care what you're setting the contents to. Oops, that needs to take a string. Contents. And then my this contents equals the contents. Come on, contents. There we go. So get and set for these, easy, right? I just take whatever value you give me. There is no wrong answer here. If you wanted to have, hey, there's a list of valid colors, we could do something like that. But I think when it comes to colors, you're probably fighting a losing battle, saying you can only have so many colored cups here. So, but how about for volume now? Volume, we do have some sort of rules around what is a valid volume here, right? So when I have a public int get volume, why is it not suggesting it? Come on. Get volume in milliliters, right? We can return volume in milliliters. Great. So this one is easy for get, but for set though, set volume in milliliters. Set volume in milliliters, capitalize. Give it an int for volume in milliliters. Fantastic. Now this one we want to be checking here because you can't have a negative volume, right? We want this cup to kind of represent something that exists in the real world, and you can't have negative volume. I'm pretty sure that doesn't work. I actually haven't taken physics before, college level physics, but negative volume seems like that would be bad here. So I'm going to say, hey, if the volume milliliters is less than 0, we'll just say volume equals 0. Otherwise, then we'll take it, right? So and really, we could save a little bit of time here and just take it first. It's this dot. There we go. Make sure we set the right one here. Actually, yeah, we can do it this way, right? Should work. Wait, I had it. There we go. So if the argument is less than 0, change the argument, then set it. Again, it gets the job done either way. Not too concerned one way or the other, but and then let me go and format this. What is the keyboard shortcut? I can never remember. I want to format document. Control E D. There we go. It'll fix up all my spaces and stuff here because I had a little bit stuff was out of line. So anyway, this constructor now here really takes the place of this one. And we don't need this one now here, so we'll comment that one out. That's EC here, because we have these default parameters here. So defaults or parameters make them optional. So if you want to give cup arguments, you give it arguments. If you don't want to give it arguments, you don't give it arguments. It will just take the defaults, which is great. So I have my class for cup. Now, this is a lot of work for set color and get color, and this is really annoying, right? Wouldn't it be nice if there was a shortcut for this? And turns out there is. Thank you to our fine folks who write C#. We have some shortcuts. So let's, I guess I'll just comment them out here because we don't need them here. I'm going to leave all those commented out. Now, what I'm going to do instead is I'm going to make these properties. So there's this shortcut idea. You have a property which says, hey, it's just public string for color and public string for contents. And then I use a set of curly braces and I say get and set. This is really weird syntax. You'll get used to it, though, I promise. Get and set. And what this means now is that you can get and set these values publicly. So I can say cup2 dot, and now I just have color and contents, right? I can set it equal to something. I already have it though, so let's take our label here. So take our label, and we'll take the text, and it equals. We want cup2 dot. I don't know. We want some nice like formatted string here, right? So let's do cup color is my cup2 dot color, and then how about my cup contents is here. Let's move this down the line here. Is cup2 dot contents, sure, and then volume as well. Add in volume cup2 dot. Now this one I don't have the volume, but I have a get volume in milliliters method that I can use, right? Because this one is a method that we can call because we still want some sort of sanity checking around the gets and sets. But if we're just taking the value, no questions asked, the property is our shortcut for that. Behind the scenes, it actually goes and generates private attributes and public functions. And anytime we do this dot color, the property name here, then it converts it behind the scenes when it gets compiled. It's super cool. It's just one of my favorite people calls it syntactical sugar. It's just a shortcut for us to do this. So we can go through and we should be able to get the wood cup with coffee, 250 milliliters. It's decreasing as we drink from it, but that's okay. All right. So we have cup with some properties. Again, nothing super interesting yet, but the gets and sets, if we want to control how these are done, we do it this way. Right? Now, other things you might do with your attributes here, depending on your cup. Like once cup has a color, you probably don't change the color of your cup. Yeah, technically you can go paint it, but let's pretend we're not going to change it here. Right? So if I don't want you to be able to change the value of color, I remove set, or I say it is a private set. This is even better here. So this essentially means the value property is set once and or set only in the class here. And really, the way that we give you access to set it is through the constructor. So if you don't tell me what the color is, we're never going to change it again. So maybe we don't want this one to be optional then. This is totally up to us. We have the choice then for what we want to do. So I'll say, hey, when you want to make a cup, you have to tell me what the color of that cup is. This is no longer an optional parameter. You have to give me a color. Then once that color is set, you can't go change it because it's private. So cup, then this one will just be, I don't know, we'll call this one glass. We'll have a glass cup here. Right? The other ones are optional. So you can have private gets, but then it wouldn't be a property because you would just make it a private value. Right? The idea with these properties is that you want something to be public here, Mo. And usually that's the get, at least. And then if you want the set to be public as well, go for it. So these are some fun shortcuts here. I'm going back to the textbook. I'm getting a little out of order here, but that's okay. Enums are fine. I'll get to tools. Yeah, got to jump back to some of these other things. So classes are really fun. That's my favorite part here. So we're doing other classes. So with a private set, that means only we can change color inside the class. It's essentially a private method with a public get method here. So if I try and I can get color here, but I can't set the color. So if I say cup.color equals red or something, right? Just trying to set it a different value, it's going to yell at me and say, hey, the property or indexer cup color cannot be used in this context because the set accessor is inaccessible. There's our fancy term, right? Our set methods or accessor. That's a mutator. I don't know. You can't access the set here because we marked it as private with that property shortcut. But the contents I can, right? So I can say contents. Then let's fill this one up with. It's getting late. Maybe we'll switch to tea at some point for my throat here. The coffee just doesn't do as well on my throat, but we're getting there. So contents you can change, right? This property with a public set can be changed. Right? And it works the same way, right, as if the value was just public. So we taught you, hopefully, and you got that idea that your attributes should be private because that gives you control over them. And the class's job, right, is to maintain the integrity of its class here. So I don't want someone coming in and just changing volume in milliliters to anything they want. I want to have control over what gets set for volume in milliliters because I need to make sure the integrity of my object is maintained. You can't have a negative volume, right? The universe will just implode, I'm pretty sure, or something like that, right? You'll generate a black hole or do something bad if you have negative volume, right? The best we can get is 0 and have a vacuum, right? I think. If you're in physics, let me know. This sort of stuff is interesting. It's just over my head. Okay, so we will put controls around our set volume here for that. Now, we don't really have any interesting methods at the moment here. These are just gets and sets for the properties. We don't have a way to really, what does cup do for us? So if we want to add more methods here for cup, like what would we do with cup? How about we have a void for drink? And it's milliliters to drink. And then, I actually want this to return something here. I'm going to tell you a bool here. I'm going to tell you yes or no, true or false, that this will work or no, it won't work here. Wouldn't a private set be useless inside a class? Well, so the private set means anywhere else in my class I can change the color. Right? So I can say this color equals something. I can set it inside the class, is what that means. So I have private access to it here. So it can be changed inside of the cup class, just not outside the cup class. And I'm sorry, I don't know what the stars came through for. So we're like, this volume of milliliters here, it's a private value. It's not a property here at this point. It's just a private attribute. So you can go and use it just like we would any other sort of attribute for gets and sets here. I don't know. I'm sorry. I don't know why it keeps doing stars. Something star tribute work in strings. It's got, I think there's some sort of chat filtering I put on. I don't know why it's attribute. Why would it block that? I don't know what it's doing. An attribute. Yeah, so if we don't have private set, I think it gets, it might actually, yeah, it might be implied, but generally you want to say that this is a private set. I think you can add just a color here. I think it'll work. It's just not a good form for us. Let's say. And when we're dealing with properties, so the little light bulb over here, it says, hey, we have a name violation. Properties should be capital letters. Right? Generally, our variable names are lowercase, but when we deal with properties, they want us to use capital letters here. I think it'll yell at me for contents too. Is that? There it goes. Yep, for contents, but nothing for volume, right? Because volume is a regular attribute. It's not a property. Oh, okay. It was a link to something. Sorry. Yeah, it filters out links. It's like a spam filter thing. I'm sorry. Sorry about that. So when we drink, then how we can interact with this cup, right? I'm going to say, okay, you tell me how many milliliters I want to drink. I'm going to say, hey, if the milliliters to drink is greater than the volume in milliliters, and return false. And you can't do it. No good. Not going to work for you, right? But other than that, if you're not going to drink that much, I'll take my volume of milliliters and subtract the milliliters to drink, and then I'll return true. Say, okay, sure, everything was good. You wanted to take a drink? Tell me how much you want to drink, and we'll go for it. We'll try it. See if it goes here. So let's add another button here then to our form, and maybe then we'll take our cup here, and we'll just do this in the same method. We'll call drink, and I want to drink, I don't know, let's just drink 5 milliliters. And it'll just keep on drinking as we go, right? Oh, yeah, if there's a dot in it. Oh, like this dot. Okay, it thinks, yeah, that's funny. So 245, 245. Uh-oh. Oh, I keep making a new one each time. Oops. So if I make a new one each time at 250 and then drink 5, it's going to be 245 each time. So let's move these here then and say I don't want them to be initialized here. Oh, I can just make a drink button. I wouldn't do that. So make another button. here. So this will be for make drinks, make coffee, and then this one will be drink coffee. Drink coffee. And just make them a little bit bigger here or something. And then when we drink coffee, there we go. We'll take our cup drink. And I don't want to have the same code in here twice, right? Because that'll make me feel pretty bad about myself. So what I want to do, I'll highlight all this. I can right click and I want to extract it. Where's my quick? Oh my goodness! Quick actions, refactoring. I want to extract method here, and we'll call this display cup. Sure. So now I have a display cup method that it wrote for me, right? Took this sort of thing. Yeah, this is Stella. Stella, say hi. Hi, Stella. She loves to be on my lap, and I'm in the basement, so I can't really keep her out, but that's okay. So now the problem, though, is cup and cup 2 here only exist when button 1 is clicked. So I want these to be class level attributes, right? So I can get at them later. So I'll have cup for cup, and I'll have cup for cup 2. So I'll tell C#, hey, I'm going to use these things eventually. Let's go for it. Right, let's give it a try. So I can, instead of creating a new instance here, it's saying, hey, that class level variable for cup, go instantiate it now, right? Oh, it's tail is a snake. Yeah, her little tail here. Stella, okay, sweetheart. You're kind of in the way. Kind of in the way, sweetie. Come here. Come on. Come down here. So should work a little better now, right? Because those exist at the class level, so I can make my coffee, and then I can drink the coffee, and now my volume goes down, right? Things are pretty good here. When I run it, though, if I drink first, crashes on me. I get a null reference exception. Right? Because it's null. We never instantiated cup 2. We told C# we were going to have one, but because I never clicked the other button for make coffee, didn't exist. Yeah, that extract option automatically generates methods for you, which is super handy. So this, oh yeah, I didn't actually fix this one over here. Oops, it's display cup. Nope, display cup, given cup 2. There we go. Now we've saved a little bit of time here, right? We don't have the same code twice. We don't feel bad about ourselves anymore. That's the general rule of thumb, right? When you're programming, if you have the same code twice, you should feel bad about yourself. The input, so I had this highlighted when I right-clicked and did the quick actions and refactoring. I had it highlighted. That's what it did for me. So I said, hey, I wanted to take this code and turn it into a method, extract it as a method. Right, so that was our cup here. So we can drink from the cup, right, as much as we want. Eventually it'll stop working, right, because we won't be able to drink enough here or that sort of thing. If we wanted, we could have a text box that says how much we're going to drink and that sort of thing. So we could drag in a text box. And this will be our drink volume text box or something. Sure, why not? And then when I drink coffee, right, instead of drinking 5, we're going to drink the convert.toInt32 drink text box.text. Right. Grab the contents of that, convert it to an integer, try and drink that much, go for it. And then after we've done that, we should probably set that text back to blank and say, okay, you drank that. This is optional. Maybe you want to leave 5 milliliters in there every time, and you could just go for it. So, hey, forgot. No, I need to make the coffee first. Make the coffee, then I can drink some coffee. Oops, it crashed here. I blanked the 5. I was going to click 5 a bunch. Make coffee, drink 5. All right, I'm thirsty, drink 15. Drink 200. Sure. Drink a big number, and it just doesn't do anything. So now then we could add in some other stuff, right? When we try and drink, hey, if it drinks, right, because this is going to return a Boolean value, right? This is true or false here for us. Then, great, and we'll display. If it doesn't, then, right, maybe I want some other sort of message here. Oh my goodness, that is not typing. Else. Wow, else. Goodness gracious, else. All right, otherwise, so instead of saying cup 2, maybe we set that label text to can't drink that much. Or something, or maybe we'll still display cup. I'm trying to think of a good way to do this. And then we can just append that in, maybe, with the new line. Maybe that'll work. So got some options, right? However we want to do that. Let's see. So now, if we make the coffee, we'll drink, 100 milliliters, great. We'll drink 100 milliliters, great. We'll drink 100 milliliters, and you can't drink that much. And notice this didn't get blanked this time. So just some ways, some choices that we have when we're dealing with our input. What do we want to do with it? But now our class is telling us yes or no, you can drink this much. There's nothing to extract at the moment. When we get the same code again, we can do that maybe. I guess we could do this here. Say, here's a little bit. You go to this quick actions refactoring and you pick extract method. It says, what do you want to call this method? This is make coffee. Sure. And now the make coffee method is that line of code that I had, and that sets cup 2 to this one here. And if you want, we can even change this around here. So maybe make coffee then takes a cup. I'm sorry, cup 2, right? And we'll say, hey, you give me a cup. We'll just call it cup. So you tell me what cup you're going to set, and I'll instantiate a new cup for you. So if I pass it cup 2, it sets cup 2 to a value, which is fun because, and this is the fun part of these being, everything's really just a reference. Everything, it's essentially a pointer. The fine details of that is not all that important for us, but I'll give it the cup, and it can go and give it a value, which is really cool. So I make my coffee. Oh dear, was not set. Didn't I make coffee given cup 2? I broke it. I broke it, friends. Make coffee. All right. I don't know. Let's put it in debug mode and see. Maybe I'm lying here. Put a breakpoint in. Make the coffee. So cup 2 starts as null. Step into our code. We have cup, which is null, equals a new cup, right? So we're going to go create a new cup here. Cup is no longer null, right? That should be good. Cup is still null. I lied to you folks. Sorry. That's annoying. So cup 2 equals. Well, that's just stupid then. All right, forget all that. We want to return a new cup. This is ugly. That's real ugly. Sorry. How about that? Cup. Make coffee. This is no good, but you can make an object, sure, and then return. Why was it not letting me pass it? Super confused, but that's okay. A little out of it. Okay, and then I didn't drink 0. Goodness, input string was incorrect. Gotta put some numbers in here. 1, 222, 222. Sure. Eventually we can drink all of it, right? Get down to 0, and then nothing should work, right? Because we just don't have any left. So, but if we want to make coffee, right, it'll remake the coffee for us, and then we can start drinking it again. Drink the coffee, make more coffee. Sure. And we're just creating a new instance in memory every time. This is getting garbage collected for us, which is pretty nice. Why are you unhappy? It's telling us our values here aren't being set. We should probably set them in the constructors. Just a warning, just yelling at us here. That's nice. So maybe let's make this nicer here. So once you make coffee, then we'll take the, what do we call this button over here? The drink coffee. Did I name it here? This is my drink coffee button. Drink coffee button. Drink coffee button. Oh, drink. I'm gonna type ahead. Drink coffee button dot enabled. It's true. We'll set it to enabled, and then in our design view, we'll set this one enabled to false. We'll say, hey, you start off disabled, right? And then when you make the coffee, then you can start clicking drink coffee, right? Now there's coffee for me to drink, and life is good here. So I'm happy with that. I think that's kind of fun. Just some fun ways to mess around with our UI. So, oh man, we've been going for more than an hour. You folks got to yell at me if we're going too late here. So we've got to take a little break. Put some music on. We'll come back, have some more fun with classes, and see how far we can get. Sound good? And then we got to talk about the next project as well. All right, awesome. I'll put the music on, and we'll go from there. All right. You folks know that take about 10 minutes. Okay. 7:16 p.m. See you folks then. Hey everybody, welcome on back. Alrighty, so I'm hoping we'll probably go about another hour or so, and then call it a day. We're going to talk about the next project too, so a couple other things I wanted to show you, and then we'll see how much we're going to leave the text for next. So I'm double checking on that here. Yeah, classes, okay, yeah, classes, good. Properties, good. Yeah, multiple constructors. Oh, good. Um, yeah, so you'll see when it talks about classes and attributes and things, um, you can give values when you declare them here. This is generally bad form here, though. So, like, I could say, hey, volume milliliter equals 0, not in the constructor. I would encourage you not to do this. I think it's bad form. Some people love it, and that's fine. But the constructor's job is to give values to your attributes. So if you're doing it here, it's technically not in the constructor, and then I feel bad about it. So you got all sorts of fun options here, but I would shy away from that here. So something like this. So we'll try not to do that one, and we'll just do the other version here. Is my preferred approach. And thanks for following along. Glad to have you here. Yeah, and then if you do have private values, one of the common conventions. Yeah, so if it's marked as private, having the gets and sets doesn't do anything for you. So you need public attributes for your properties there. This idea of the information hiding, right? We're encapsulating our details, doing public and private values here. So I'm skimming through the chapter here, making sure I'm not missing anything. Yeah, properties. It's fine. Yeah, gets, sets. All right, other fun things we can do with properties. Now, cup's not a really good example for this one here, though, but you can have other properties that are computed, which is pretty cool. So here's a fun one for that. What do I want to compute? This is volume. Yeah, cup's not very good for this one. I guess not all cups are round either. All right, so let's just do another class because that's much more fun then. So let's add a new class here. I'm going to go to the project level, right? So this is the solution. This one is the project. Right-click the project. Go on to add a new class. And I'm just going to steal his example here because this is easy here. So this is a rectangle, right? Rectangle. Oops, I want to call that rectangle. Now, you can have, I can't spell, it's not spelled right, is it? No, it is not. Rectangle. There we go. Your name of the class doesn't have to match the name of the file, and you can have more than one class in a file. I'm generally of the school of thought that one for one is better. I started with Java, so that's sort of what you're forced into in Java, but that's the form I like. It makes your GitHub history a little cleaner as well, to just have one class per file, but it's not necessarily a hard and fast rule. I mean, I have a set of cups that are mostly square. They're like rounded squares, so I wouldn't call them round. And then if I were to like try and compute the volume of a cup with like, here's the circumference and here's the height or something, the math just doesn't work out right. So I don't know. That's why I went away from that fluffy. But for rectangle, right? So we're going to have a public length here, and my goodness, length, and that should be a capital L. So public int length with a get, and we want we want to have some control over set here, right? We want to control what's happening when we set these things. So you have some options if you want when you're doing these, a little bit of a longer, more verbose way of setting these. It gets a little funny here. So you can, and you might see some of these here. So we might say get, and then we can say So this is get return length, and oh my goodness, why I'm missing, there we go, one more set of curly braces, there we go, get and set length equals the value, but only if certain things are true, and this gets really funny here. So then we could have a private int for length. This gets convoluted. So we're saying, hey, here's my private value here, here's the public property, we can get and set this way, and then you can put controls around your sets. I'm not fond of this here, but it's some sort of a syntax here. You can. And some people do. So you'll see something like this in certain places here, and that's okay if you want. Not the end of the world. But now in our set, right, we can check and say, hey, if value is greater than 0, let's do this thing here. And again, I always like curly braces. I will always recommend you use curly braces, even for single liners that don't need it here. Right? It just makes life better for you to have the curly braces, because years ago, you folks are probably all too young to remember, the Safari web browser had a vulnerability where you could essentially bypass some of the SSL, secure connection stuff. It's because one of the developers at Apple did not use curly braces, and they had 2 statements underneath the if block here. And they wanted both to run, but they both didn't run, in all cases. So you got to be careful. So I always like the curly braces. It doesn't hurt anything to have them here. And then, hey, if you're like, hey, for my code metrics, I'm writing more lines of code. Sure, looks fancy. Whatever. Control K and D. Is that format? No. Control D. E. Oh my goodness, I don't even remember anymore. Advanced format. Control E. Control E. Control E. D. There we go. Formats it for you. There we go. So it puts all my gets and sets. So you can go this approach here if you want to control what's happening here in your length. And then in your form, right, we'll say, hey, why not? We'll do that in, doesn't really matter, one of these quick things here. We'll say I want a rectangle, small rectangle equals a new rectangle. And then my small rectangle dot length is equal to something here. Right, so I get the same syntax. So it is kind of nice to get that same syntax, and then you still get some of that checking around what values you're being given here. So in some ways it's nice here, but it's a small pain to have to go through and do all of this other stuff. Am I missing a curly brace? There we go. It's missing another curly brace. So it's a little bit verbose for length, but then you can get some sanity checking around a property if you want. All right, and we're going to do the exact same thing here for width, because we're awesome. So we'll have a private width. So the underscore is generally used for private values, so that you see the name of your variable is private. That's all. So it's just another convention. Not a hard and fast rule, but that one's pretty common as well. Okay, so we have length and width. Now, an interesting property here, right? Other things we can do with properties. I can say, hey, I want a public int for area is equal to, and now I don't actually want equal to, I want this arrow notation. This arrow notation is really cool. It's essentially giving me an anonymous method, which is fun. So we're going to take length times width. And I'm stealing this right out of the book. I apologize. But it's a nice, quick little easy example here. So this capital A area, right, because this is a property, is a computed property. There is no value stored for area. It's just computed here, and then it's not anything you can set. It's just you get this value only. So in my form here, I can get my small rectangle dot area, and it looks like a property, right? But we can't assign it anything. It's going to yell at us if we try to assign. So this can't be assigned to. It is read only. It even tells us, hey, this one's read only. So you can't get values here, but you can go and print the values out or do something with it here if you wanted. I don't know, add it to another label somewhere, but that's sort of idea. So we'll take our small rectangle, take our width is 5, sure. And we can access it. So it's just shortcuts. It's just ways of letting us get at these values without saying .set and .get. It's just syntactical sugar, just some shortcuts here. But these properties are very common here. They're a nice way to have, if you just have a bunch of attributes, it makes your code a little more concise. All right, yeah, I probably need to set a label somewhere for that. backslash area of a rectangle is, and then do that as a formatted string. Okay. Kind of like a pointer. The properties, no, they're just shortcuts. It's just a way to not have to write a method for get area and return this value. It's the same as if I had a int get area and it returns length times width. Right, exact same thing here, but now I get the dot area notation instead of dot get area. So I'll get the exact same result one way or the other here. One is just sugar get area. So because you have to type like 3 less things, I don't know, 3 less letters, I don't know. So people are really fond of properties. It's just some shortcuts here that you can use. That's all. Getting values. So now I did say I don't like setting values here. If it's a property though, it works. You can. Some people really like putting them there. The author likes putting stuff there with values. Totally up to however you want to go about it. I don't like putting values in my properties, but you can if you want. Just a form. All right, what else we have here? Yeah, we'll come back to static more later. I think that's not, we don't need to worry about that right now. And then nulls, we'll come back to that. Null operators, yeah, those are some other fun things we'll get to. Okay, so some basic parts for our classes now. I think we're in pretty good shape here. I want to show you the next thing that we do with classes. So when you write code, you want it to work. Right? That's the goal. You want working code. And most of the time, what you've done to see if your code works is sort of what we did here. Like, okay, I've made a class for rectangle. Where did I even put that? I don't remember where I put it. Right here. I'll go use it and see what my output is. Because I expect the area to be 10 times 5 would be 50. Right? So it should work. I should get area of rectangles 50 here when I make coffee and drink some coffee here. Looks like it works. So we are eyeballing it here. We're testing it ourselves. And depending on who you had for some other classes, you might have had lots of fun in 200 doing test plans and test cases and thinking about that sort of stuff. And that is fantastic. You should know what the output is for a given input, right? If you don't know what it is, then your code, like you probably don't know it well enough to write the code to do it. So that's sort of the idea here. So something goes in, something else comes out. We know what should happen here. So yeah, definitely, Straw Hat. I'll catch you later. Let me know if you have any questions later. So if we know for a given input what the output should be, we can test it. And that's what we did. We eyeballed it here, but it turns out humans are really bad at this, right? If you've ever proofread an English paper, you'll know how bad we are at this because you know what you're expecting to see. And a lot of times you just don't miss, or so you don't see or you do miss when it doesn't match because you already have it in your head. So what we want to do is we want to make the computer do the testing for us because the computer is not going to miss things and it's not going to get bored and it's not going to care if it has to do it 50 times. It's going to do it over and over and over as often as we want it to run. So when we write classes, the idea here is that we can test our classes at sort of this unit level. So we're going to look at something called unit tests to say, does this unit of code do what it's supposed to do? Right? So this idea of unit testing is I'm going to take a small chunk of code and test it to make sure it does what it's supposed to do. So generally we do this when we start talking about classes. So once I have my classes that I am working in, I can make sure that all of their methods do the things they're supposed to do. So I'm going to come to cup and the cup class. If you right click on it, you can say create unit tests. This is why Visual Studio is fantastic. So it's a really nice tool here. We're going to make unit tests for cup. There's all sorts of cool test stuff you can do. There's other testing frameworks. It's all well and good. MS Test is all we need for now, right? There are better ones and there are fancy ones that do other cool things, so we don't care too much right now. So I'm just going to take all these defaults. So it's going to make a new project for tests. So the idea with a solution is it's a group of projects. You probably have only ever had one project per solution. That's just my guess here, because that's basic. But what we get to do is when you have multiple projects inside of a solution and you go and build your code, and I want to go and say, give this to my customer, and they're going to go and run it. I don't want any of the test code to be built in to what I'm delivering. I don't want it to be part of that deliverable. So if we put it in a separate project, what we do when we build our program to run it and deliver it, we can exclude the test project from it. So none of the test code is there. It doesn't add any bloat, and they don't need it, and they're not going to run any of the tests, and they don't care, that sort of thing. So by having these different projects, as we go and build and deploy our code, right, and have people run it for us, we're not actually going to do a whole lot of that ourselves, but it sets it up so that you could in the future. So we want a separate test project for all the test stuff to go in. And then all the names here, tests is great, namespace tests is fine, new test file, tests, class tests, method tests, and then failures are good. So this is all going to generate more code for us. If you want, you can do it by hand. You can right-click the solution and say, hey, I want to add a new project. And then in your projects, you can go look up test here, and you can find the test MS test project and go and add that. There you can add NUnit, that's another great one here. You can add XUnit, that's another great one here. All sorts of other cool tests, but we're just taking the defaults here. Visual Studio test tools, unit testing is nice and easy. It's going to work for us here. And what we get now is we get a bunch of methods with some of this cool annotation stuff. This is all annotations. It's not code, but it's letting the compiler know it's going to do something special. Saying, hey, I'm a test. So, and we get a couple tests. It generated, so every method that it found, it generated a test for us. Now, just one, and that's okay. We can come back here. So what we like to do is we like to name these something meaningful here. Now, I'm sorry, this testing part's not in the book. That's one of the downsides, I think, to RB's book here is he doesn't cover tests, but I haven't found a lot of books that do. And it's not worth buying another book just to talk about testing, because you can look this stuff up or just come back to the video here. Excuse me. But what we want to do is make sure that our cup class does what it's supposed to do. So we're going to make a bunch of tests here. And when we talk about tests, there's this idea of code coverage. Code coverage means when the test runs, how much of the code in this class that I'm testing is actually running. Right? So when this constructor runs, these 3 lines of code run. Great. When drink runs, these 2 might run, or these 2 might run. Right? This line of code might run, or these 2 lines of code might run, depending on whether or not this is true. So when I'm testing my drink method, if I want to have this idea of 100% code coverage, if I want every line of code to run at some point when it's being tested, I know I need to test it twice. I need to test it once for this case and once for this case. Now, you can get tools and you can pay for tools that will measure this stuff for you. There's some really cool tools out there. I'm not fond of spending money on things. So we're just going to eyeball this idea of code coverage and say that's good enough, right? And I think the more expensive versions of Visual Studio will even do this for you without any of the extra stuff. It's been a little while since I looked at it here. But we're going to say, okay, I want to make sure that all of this stuff works here. So in my cup test here, this is really the cup constructor test. Here, I'm just going to rename this here and say, okay, I'm going to test the constructor. Can I give it values and get them back out? Now, when I'm testing the constructor, I'm also testing the get method. Because to get the volume of milliliters, I have to call the get method. So I don't usually test get methods separately. I test them in the constructor. Now the set method I'll come to in a minute, because this one has some cases here. We'll get back to that in a minute. So for our test constructor, what we like to do here is we like to follow this format called the AAA convention, or AAA format. So we're going to arrange the variables we need to test. We're going to act. Well, here we go. We're going to act. So we're going to call the code we are testing and get values back out. And then we're going to assert, did we get what we expected? Okay, so for testing cup here, I'm going to say, hey, I need a string for color. We'll say, hey, this will be my wood cup here. I'm going to have a string for contents. This will be coffee. I'm going to have an int for volume in milliliters. Milliliters. There's 2 L's there. Milliliters, isn't there? Milliliters? I don't remember. We'll say it's, 250. Why not? We can use those same details here. And these are really my expected values. I'm going to have an expected color here. I'm going to have an expected contents. And I'm going to have an expected volume of milliliters here. So I have expected values. So these are what I expect to get when I test my cup. Okay. So now the code that we're testing the cup constructor. So we'll say cup equals a new cup, given the expected color, the expected content, and the expected volume in milliliters. So I'll give it those values here to the constructor. I should get them back out. So we call the code we're testing, which is the constructor, and we're going to get the values back out. So I'll have a string for the actual color here, right? It's going to be my cup dot color. Let's get that color value back out. Oops, there's my semicolon. Wonder why I was confused. And then we'll have a string for the actual contents is my cup contents, and a string for the actual volume in milliliters. I don't know why I didn't pick that one up. That's okay. I'll just go copy paste equals cup dot get volume in milliliters. Again, we're using that get method here because this one we didn't set up as a property. Oh, that's not a string. That's an int. Oops, sorry. Here's an int. So we're getting the actual values out. Then did we get what we expected? So this is assert dot r equal. So there's a bunch of different asserts. Most of the time we want r equal. There's also like an is true or is false, is null, is not null. We'll get to some of those later here, but we can say r equal my expected color, my actual color. Assert dot r equal the expected contents and the actual contents. And then assert r equal the actual expected volume in milliliters and the actual volume in milliliters. I'm not typing most of these things. I'm just doing a couple letters here. So the computer will check and see, do these things match? Are they equal in value here? And then I can right click and I can run my tests here, run tests. So you don't want the run program. You want to right click and run tests, because running the program will run your form, right? That's the project that is going to run here. So assert says, I expect these things to match. I'm saying this should be true. Now, it says down here in the bottom, it's real small here, but it's probably hidden in the Test Explorer window. If you don't see it, you can go to Test, and you can go to Test Explorer. Open up your Test Explorer. This is a fantastic little window here. And you can see that in cup tests, the cup constructor test passed. I get a nice little green check mark here. The drink test and the set volume test failed, because they just failed. We didn't have anything here. There was nothing. I think we run all tests again here. Do we want to run all tests? There we go. Now they failed here. There. Okay. So before, sorry, when I right click here, it only ran the one test. If you go up to the class level, you can run all the tests, or just go to Test Explorer and run them all here. So drink test failed. Sure, this is fine. So again, we expect this one to pass. It was not very interesting, but if we like change this here and say, hey, I expect 0, and what is the actual volume in milliliters? And I run my test now. Run this test. We're going to see that it fails. And it's really nice because it says, hey, the assert equals failed. And you can kind of open this up and see it expected a 0. It actually got 250. So just by looking at the test, you can see what went wrong on it here. You know, this is the expected value. So expected value is first, actual value is second. Perfectly fine here. So I'll put that back, right? Because we want that one to pass. Now, some people don't like putting all of these here. That's okay. Not too big of a deal. The other place you can just put it here is just say, hey, it's the cup color in the assert. You don't necessarily need it in the act. I'm fond of having them here. It's not necessary though. So some people will put them down below. I guess I'll leave that one commented in case you want to see it, because I guess that's a nice little shortcut. But what you don't get to do, though, it's harder to debug these. So what's fun is that because this is code, I can debug it. So I can put a breakpoint here, and I can debug my test here, and I can watch it and use the debugger and say, okay, I'm ready to run this line. Let's step into my code here. Let's step into, and now I'm in my cup class, and I can see what's happening. Now, again, get volume is not a very interesting method at all. But if we're testing more interesting code, right, you can see and step through line by line by line and see what's happening. So I prefer those to be in the act section, just so that I can step through, and that way assert is just, does this match this? There's no code actually running here, because again, just more of a style preference for myself, but not too big of a deal. And we can continue, and then our tests pass, and then we're happy. So we need to fix the other one. So drink test. Now drink, we said, has two different things that can happen in cup, right? It could return false, or it could return true. So I'm going to check both cases here. So I'll say drink test returns false for the first one here, and then we'll do a AAA format here. So we're going to arrange, we're going to act, we're going to assert. So to arrange, I'm not testing the cup constructor. So I just need a cup here, equals a new cup. And I don't really care what the color is. I don't care what the contents are. But I do care how much volume it has. I don't know. So I'll actually make an integer for it. So int expected volume in milliliters. We'll just copy this one here. Why not? We'll steal that one and put that in here. So I'll make a cup. Now when I act here, I'm going to have a Boolean for the result. Then is going to equal cup.drink. And how much do I want to drink? Well, I want to drink my expected volume times 2. Because I want it to return false. If I try and drink double the volume, I should get back a false. The other thing I'm going to test here then is the actual volume in milliliters as well, because this value should not change here. So then I can assert that those match. Stella, you're in the way. And then I can also assert is false my result. So 2 things, right? It should tell me no, give me back a false, and the actual volume should not change, right? It should be what I started at because it doesn't change. So when we run our test here for this then, we run all of our tests. Drink test returns false. Oh, it didn't run. Run that one. There, now it passes. So it is doing what we expect. So I'm going to copy paste this whole thing here. And then this is returns true. So now I'll have my expected, this is really my starting volume in milliliters here. And then I'll have an int for expected volume in milliliters. Again, let me just go back to this one. After we drink some, it should change. So let's maybe put this down to 200 or so. And then I can drink 50 if I want, or something, or I could do the arithmetic. And I feel a little bad having a number here. I guess we could do this minus the expected. Right, so if we drink 50, it should work, so then we should assert is true. And then the expected volume is the actual volume. So after we drink 50, or 200, 250 minus 200, because that way if I change these values, I don't have to change over here later, just to make my life a little easier. Let's give that one a run. So let's run this test and see if this one works for us. So it should return true, and the volume should change. And it passes. Right, so that one's great. So now the set volume, again, we have 2 different cases here. So this is returns true. We should be able to set the volume to something valid, and then returns false if we set it to something. I'm sorry, no, this one doesn't return. My mistake. It sets it to 0. So in terms of code coverage, just giving it something less than 0 and making sure it goes to 0 technically fits the bill. I don't really love that. So let's say, okay, so instead of returns true, this is just normal, and this one, negative values set to 0. Sure, why not? You can come up with any name you want here. You want it to be descriptive of what's happening here. Totally up to you. So we're going to arrange, we're going to act, we're going to assert. So I need a cup. Now equals a new cup, and then all I need to give it is a color, right? Technically, I don't have to give it any of the other attributes. So that's fine. And then I can say set volume in milliliters to, and I'll have the expected volume in milliliters. Sure, why don't we do 200 here? Why not? We'll set it to the expected volume in milliliters. And then we'll go and get the value back out and see if it matches. That one goes up here. There's no result. Oops, no result. Okay, so make a cup. It should default to 0. Then we're going to say, okay, let's set it to 200. Did it set to 200? And are we good to go? So we can run that test. Let's run our tests. There we go. That one passes. And now our last one, right, still fails because we haven't finished it yet. So we'll do another one here. Now in this case, let's make a cup that has some sort of value. So I'll say I expect it to be 0. I'm going to start it with a value here of like 250. And then we go and set it to, I don't know, like negative 100. I don't know, sure. Some negative value, right? Because I think that was our code set. If it was less than 0, set it to 0. We could say less than or equal to 0, maybe. That might be a little cleaner here. We'll just set it to 0. Is that fine? That's probably fine. So if you set it to the actual expected, we just want that line of code to run, essentially. Should set it to 0. That's not even, all right, I don't love that. Let's set it to negative. Because that's what the test says, and that's what we were trying to check. It's functionally the same thing, but that's okay. let's run the test. Excuse me. I'm losing my voice here. I don't have much longer. All right, and our test passes. So when we set it to a negative value, it actually stops at 0. Right, so now we feel pretty good about cut. We could do the same thing with rectangle, right? We could write tests for rectangle, for length, for width, for our values being less than 0 or greater than 0. Get area just gets computed, right? We can check it all out. So the idea is, if we know what's happening, we can write our tests to test for it. So the next cool thing about that is, as we start adding stuff to object-oriented and tests, if you're using some sort of tool like GitHub or basically any of the providers of Git services will do this sort of thing for you now, is that when tests run, I'm sorry, when code is changed, you can tell it to automatically run the tests in the cloud or on some sort of location, that sort of thing here. So if you go and look up, I think we had like Microsoft, we looked at them before. Here's the VS Code. So when VS Code, I think it's in here, right? Is this the one? Maybe it's not in this one. What they had, yeah, they have all their tests. So where do we see? I think it's under actions. Yep. So when something happens, this is the CI. This is the one here. When code is changed, this continuous integration, so CI is for continuous integration, it will go and run all of the tests for you, and you can see if they pass or fail. So when someone changed something here, these tests failed, we get a big red X here, we know bad stuff happened. So as we're going through the workflow of let's change some code and let's get it integrated into our source control environment here, like GitHub, we can go and run these tests on someone else's computer out in the cloud. I don't need to run all the tests here. So as we're building a large project and we write tests for our code here, it might take a little bit of time to run all the tests, especially as we're testing other code. So if we can have all of our classes have tests and all the tests pass, we should feel more confident that our code is correct and should do what it's supposed to do. It doesn't mean it's perfect, and it doesn't guarantee that we'll have bug-free code, because it's still possible to screw it up, and it's possible to screw up your tests as well. But you should have a better confidence that things work well. And then what happens is, as your code gets maintained, right, because it costs a lot of money to have developers write code, companies are going to want to use it for a while, and as you're using it, occasionally things need to change. If you have to go and make changes here, you can change the class, whatever we need to do here, add more logic or change something around here, whatever the case happens to be. If the test stops working, you know you broke something important. You changed some core functionality. You changed some behavior that was expected. And now you have to go fix it. So building tests makes your code more resilient to changes as well, because it's a little easier and safer to change. It makes your life easier. And hooking them into your continuous integration environment through source control makes this even easier for you, because it happens automatically. And then the next thing that you can do, depending on what your product is, it doesn't work necessarily for all products, but if you have a robust test system in place that is not just unit tests, but you can also run integration tests and system tests and end-to-end tests, and kind of do a fake full deployment of these sort of things and run tests. You can automate all sorts of cool tests that you want here. You can then move to what's known as continuous deployment. So it's this CI/CD, or these pipelines, CI/CD pipelines, is that you can then automate the deployment of your code. So a lot of places that run websites, like GitHub itself, actually runs on continuous deployment. So as developers of GitHub work on the website, they can check their code in. If all the tests pass, it will automatically go and update github.com to the working version. So I've got some friends who work over at Khan Academy. It's a fantastic place, by the way, especially if you need help with math. They have the same process in place. So as they make changes to the code that runs the Khan Academy website, they can check it in, and then it will automatically get deployed by these automated processes. So by having the tests in place, we have more confidence that things will work, and we can get the system to a place where we can automatically start deploying it here. So, throughout the day, the website might change 15, 20 times a day, because developers can get their changes out into production quickly. And that's generally where we'd like to have changes be done. Obviously we want some sort of testing on it, and there's processes in place for that sort of stuff. And that's all the fun stuff of software engineering and the software engineering process. But the faster we can get our changes as developers out to users, the easier it is to get feedback on whether or not this is working for them and that sort of stuff. So using tests and these CI/CD pipelines is fantastic. CI/CD pipelines. Look at that. GitHub. Look at that. GitHub blog. How to build a CI/CD pipeline for GitHub Actions in 4 simple steps. Look at that. And just go Google it. You can do lots of fun stuff. So depending on what you're building here, it's pretty fun. It does this sort of stuff for you. And again, not every tool necessarily works like that. For building a forms application where someone has to double click an exe, it's not going to work as well. There are ways to do these sorts of things, and you can have like automated, updated applications and whatnot. Like the GitHub desktop client itself will say, hey, you have to update to restart. Like every so often when it restarts, it updates itself. So you can make executable software also do it. It's not just for web software, websites, but there's a whole other process that goes into that, and that sort of fun stuff. But lots of cool things happening there. So testing was new, but this idea of getting 100% code coverage is great. I like to say any code that's worth writing is worth testing, because if someone's going to pay me to write the code, they want to pay me to write working code that does what it's supposed to do. And by writing tests is how one step of the process of making sure it does what it's supposed to do. Right? It's one layer in the system here. It's not the only one, and you can still do other testing. You can do manual testing, that sort of stuff. But it's a great tool for having more confidence that your code does what it's supposed to do, which is really cool. So we're going to be working on building a class and testing our class to make sure that it does what it's supposed to do, that sort of thing, in our next project, and then building it into a fun little user interface. Okay. So I was talking to someone. I'm really bad with names. I'm sorry, but we're going to build a game here. Hopefully you guys have seen Yahtzee before. Yahtzee is a fantastic game. Where's our Wikipedia page for it? Where's my link? Yahtzee.game. Nope. Oh, right there. I just missed it. So Yahtzee is a dice game that is based on rolling 5 dice and getting certain combinations of dice to score. Works out pretty well. So you have the upper section of your score box and you have the lower section of your score box. The upper section, the score is just the sum of dice with that number. So for scoring ones, I don't know why they call it aces. I always call it ones, but sure. If you have 3 ones in your set of 5 dice, your score is 3. If you have 3 twos, your score is 6. If you have 4 threes, your score is 12. Right? It's the sum of that value here. So as you roll the dice, you can score in these different sections here. So you have 6 sections in the upper section. You have 1, 2, 3, 4, 5, 6, 7 in the lower section. So you have 13 locations to score here. And what happens is once you've scored that location, you're done for that game. So there's 13 turns for each player where they'll roll the dice and you get to roll your dice 3 times. So, and probably the easiest way to do is just to play it here. Not calculator. I don't want that. I just want Yahtzee. I think this one was fine, actually. Card games. Yeah, this one was fine. So here's my scorecard. Here's Bill. So we can play against Bill. So you start off by rolling your dice. So I've rolled 5 dice, and then I get to pick which ones do I want to keep and which ones do I want to roll again. So in this one, I want to keep my 6s here, and I'll roll again. I didn't get any more 6s. Bummer. I get one more roll. Okay. I didn't get enough. So I could score 6 in my 3s. I could score 4 in my 4s, 12 in my 6s. None of these other ones have any points here. I don't have a 3 of a kind. I don't have a 4 of a kind. I don't have a full house. I don't have a small straight. I don't have a large straight. Chance is just the sum of your dice. You get that one time. It's like a throwaway. And then a Yahtzee is 5 of a kind worth 50 points, which is kind of fun. So the idea is you just want to get the highest score possible. So in the upper section, if you can score 63 or higher, you can get a bonus 35 points. 63 or higher means 3 of each, essentially. 3 6s, 3 5s, 3 4s, 3 3s, 3 2s, 3 1s will get you to 63. Get 63 or higher, you get your bonus. Is it 63? I think it is. Here's the bonus. Wow. Really? Bonus. Yeah, 63 high. It is. Okay, I did remember that. So I'll score it in my 3s here because it's better to have a less 3 than it is to have 6s. And then Bill goes. Sure, that's fine. He can have his turn. We watch him play. So he rolls different dice. He wants to keep his 5s. Go for it. He rolls again. He didn't get anything great, so he kept his 4. So now it's our turn. So we'll roll. Let's try for 6s again. Why not? So we'll roll. Try again. Nothing. Okay. Not a great roll again, but now I'll take my 2 1s here, and then it's Bill's turn. So you don't have to play against Bill. So when we are building out our game, we can just do single player. It doesn't have to be Bill. But what we want to have is 2 players. So you could be player 1 and player 2, that sort of thing. Because having multiple players will help us with our object-oriented design to make sure that this works as well as it should. Let me try for 5s here. Nothing. Wow, not very much luck. But now you see I have a small straight. So 5, 4, 3, 2. So 4 numbers in a row is a small straight. I'm going to keep that here and score my small straight. And Bill's turn. So if we have a good object-oriented design, right, the different players, the only thing that's different really is your scorecard. The logic of the game is identical here. The same thing happens, it's just we're going to score it for this player or we're going to score it for this player. So we roll the dice again. Let's go for 5s. Why not? Hey, all right, I got 3 5s. Feeling good. 4 5s. All right, so we could score the 4 of a kind. If you have 4 of the same number, it's the sum of all your dice. And 4 of a kind is also 3 of a kind here. Or I could score 20 in my 5s. That'll make up for my missed 3 and my missed 1. I want to score the 20 in the 5s here. I'll let Bill go. So we're going to build our own Yahtzee game here. So we come to assignments, make a new project. This is project 2 Yahtzee. So this will be due in 2 weeks. We got a little more time to work on this one here by 6 p.m. And let's say this is going to be worth definitely a little bit more here. Let's go to 20 points for this one here. Because there's a lot more happening here. So there's the Yahtzee game, build a 2-player Yahtzee Windows form game. No computer player. Right, so the 2-player being, you could pick for both players here. Let me go and set up a GitHub Classroom link here so you can make a new repository. Yeah, so for random numbers, I'll show you that in a second. It works just the same. Super easy. CIS 29, winter 2023, project 2. This will be my C# template. Awesome. And create. So you're welcome to just use labels instead of pictures. You can do pictures. It's not too hard to do pictures. So in the Windows form here, let's just go and go to my form. If you like pictures, you go to your toolbox, you grab a, oh man, where did it go here? Picture box. Picture, there we go. Picture box. And then it gets a little funky here for adding images. So with the picture box, you can go and choose an image. And then you can go and find an image somewhere. So you're going to add images here to this properties. You can go and import them. Perfectly fine. If you'd like to do that, that's awesome. That's the sort of thing, like, it's prettier, but we don't need it. So you're welcome to just use labels to start. So for C# random value here, we use, let's take a look at this first link here. You use an instance of the random class is usually the easiest way here. We do next. So random, we'll set this up here. So if you want a random number, let's just go to our form here. So how we do our random rectangle? So we'll say random equals a new random equals new random. And then length will be random.next, and you give it how high and how low. How high and how low, your min and your max here. So the min value, let's say, is 1, and the max value, say, is 100. We'll do that again over here. Now, it's not a great random number generator. This is a pseudo random number generator here. So don't use this for anything that needs cryptographic level random security sort of stuff. It's not perfect, but it'll work for what we need it to do here. So like when we go and drink our coffee, we should get random values from 1 to 100. Make some coffee, drink some coffee, right? And each time we should get some different numbers here, right? Just fun. 241. Okay, there we go. And now we can see we just get a bunch of random numbers, right, as we go. So it's picking random numbers for us. So your first roll, you roll all 5 dice, and then you get 2 more rolls of any of those dice that you want. So the next roll, you could roll all 5, you could roll all 4, you could roll all 3, you could roll all 2, you could roll just one of them if you want. Right? And you get 3 rolls total here when you play. Yep. So you can generate random numbers here. So yeah, this was telling me the area. So up to 100 times 100, we'd expect to get, an area of up to 10,000. I think it doesn't actually get all the way up to 100. I gotta remember here if it is within range or not. Why doesn't it? This one's not helpful. Max value. Yeah, 100 times 100. Yeah, okay, so it is not inclusive of the upper bound. Thank you, Stack Overflow, because I can never remember here. Okay. So what we want to do when we're working on our program here, we need a way to generate what these possible scores are here, right? So if you think about the different things that we have, like there's a scoreboard, and each player has their own scoreboard, right? And then we can generate possible scores given a set of dice here. So for any 5 dice, I should be able to generate what are the possible scores I can have here. And then I can go and set the score when I pick which one do I want here. So this will set the score for me here, but it's generating all the possible scores. Now these other ones are just zeros. You can pick it, but it's like, hey, it's going to be 0. Are you sure you want to do that? This is just like a nice little helpful hint here. So you can take a 0. So like once you've scored all of your upper sections, you don't always get to score these other things here. So let's see if I can continue on here. I was going to throw some, let's do, oh, we already have a small straight. So let's keep 2, 3, 4, and 5. So I get a 1 in 6 chance to roll a 1, a 1 in 6 chance to roll a 3. So I have a 2 in 6 chance or 1/3 chance to roll a 1 or a 6. And I get to do that twice. So a 4/3 chance, I'm sorry, 2/3 chance total. There we go. And we get our large straight. We got lucky that time. So again, we'll fill all these in here. So yeah. So you have to have the scoreboard. So you have to show the possible scores the player can score. Allow them to save that score to their scorecard. Right after the game is over, allow them to play again. Reset the scores and rolls and stuff. Sure, that sort of thing. We can reset it here. Okay, so as we're doing this, then let's turn in our URL here. So we're going to submit the URL to your repository. We're going to get points for our design. We're going to get points for the game working, and we're going to get points for actually testing it, that it does what it's supposed to do here. Because you don't want to have to play every single possible hand of Yahtzee to make sure you can score these things. I want to be able to say, hey, if these are my 5 dice, if I have a 1, a 2, a 3, a 4, and a 5, I should be able to score a large straight. I should be able to score this. I should be able to score this. I should be able to score that. So that way we can test our code very easily without having to play the game, right? We can say, okay, hey, scoreboard, the value of your 1s should be this for these 5 dice. So Bill is the computer player. We don't need a computer to play against us. We're just going to have 2 players, but the person sitting in the seat running the program will be player 1 and be player 2. So by having more than one player, it's going to help you with your object-oriented design to make sure that it's not all just designed for one person. So this way, if the same thing happens for player 1 as it does for player 2, it's going to help you have a better design here. The person in the computer seat is both player 1, player 2. I'll put this down here. Thank you. Multiple players helps with the object-oriented design. Object-oriented design. Okay. So we're going to turn this in, and then I am open to you folks working with partners on this if you want. I think you might actually have a better product at the end if you want to work with partners. Setting that up in Canvas is obnoxious, so I'm not going to do that because it gets a little annoying. It's doable, but it's a small pain, and then you have to put yourself into groups, and we'll get that when we actually get to the group project. But for partners, it's not really worth it here. So you may work with a partner on this if you want. So not save. I'm so used to hitting save. So if you want to work together here, I can give you both access to the same GitHub repository, so you can both push and pull from it. It gets a little funky sometimes if you're both changing the same file at the same time. It's good practice because eventually we're going to be doing that for the group project. So if you want to get into that now, shoot me a message. I need just send me a message with the GitHub usernames of both partners. Make sure at least one of you accepted the assignment via the classroom link. Right, so you accept the assignment, and then I can add your partner to have access to your repository. So you can work together on this if you'd like. Everyone must submit individually. So even if you use the same repository, I still need you both to submit, because otherwise Canvas won't know that it's going to grade here. Okay, so we need to design a solution that allows you to see what possible scores you can have for a given set of 5 dice. Right, so that's the idea that we need to be testing here, because that's the important piece of what we want to be testing. Now, testing UI code is rather difficult, so there's not going to be a whole lot of stuff that you're going to test in the form itself, because really all your UI should do is say, hey, class that you wrote, business logic class, please go do this thing. Right? It doesn't need to track a whole lot of things inside the form. Now, you can build the entire Yahtzee game inside the form, but that's not good object-oriented design. So what we want to do is make sure that we're having good design here. So you can see whatever scores you have for your given 5 dice. So to do that in a way that you can have 1 player and 2 player, we need a class for, hey, here's the scorecard for some given dice. Right? So your score, you can have a scorecard class that accepts a bunch of dice, or you can have a class for Yahtzee dice if you want to have all that logic for dice built into the class itself. Because sometimes when you roll some of the dice, but you don't roll other dice. So how do we do all of that? There's a lot of design work that goes into it here. I've got ideas on things that we can do here, but there's not a right way to go about it here. So any way that gets the job done will be okay. But we want to try and design it well. So spending time thinking about these things is worthwhile. And this is why, back in 115-200, we spent a little bit of time talking about the UML, our unified modeling language, building out class diagrams and activity diagrams, and how do these things flow, and what's the workflow like? Because if we can get a picture down, we can get an idea down in our head, then we know what code we need to write. If you just start trying to write code here, you're in for a hot mess, because you don't have a plan. So you want to sit down and think about, what does it look like for that? And for design process, I'm perfectly happy with you folks talking, everyone in the class can talk about design together. The general rule of thumb, right, is as we're talking about what we want to do, if you have to start taking notes, you've probably gone too far. Like, I'm not going to say, hey, my code will do this, and then do this, and then do this, and then do this, and then do this. But like, hey, I'm going to have a class for scorecard, and you'll give the scorecard a set of dice. Great. And then it will tell you what you can have. And then the player will have a scorecard that they'll go and set their values for. Right? And we need to know whether or not the value has been set, because having been set or being 0 is different. Right? So I don't have a 0 here. It's just not set. So we have to be careful here, because you can't change a value once it's been picked. You only get the 13 rounds to get all 13 values here. So let's see. Let's do a 6. I really want some 6s here. Got to do better. Okay, so we got 3 6s. That's pretty good here. We'll take that. So I can't now go change the value of 6 here. That sort of thing. So that's what we're going to be working on doing here. So let me build out the rubric for you here, so you know how we're going to score this. Where do I add? Am I dumb? I don't see it. Why don't I see rubric? That's fine. There. Okay, now I can add a rubric. Okay, so this is for Yahtzee here. So for the 20 points here, we're going to we'll do this for grading. I have a couple criteria. So this is our object-oriented design. So not everything, or so we have classes or business logic that the UI interacts with. So that's minimal code, minimal logic is in the UI here. Right? Most of what the UI needs to do is say, okay, you clicked a button, great. Here's this class call a method, and then display the results. That's really what the UI's job is for, right? So we want the UI should call the classes and show results. That's the UI's job here. Okay, and then we'll have our correct Yahtzee game logic for scoring and play. Now this one is worth more, right? Because there's more to it here. So let's say this is what do I want to do here. I think 5 is probably okay here. So we'll do that, and then we're going to have points for unit tests. Unit tests for Yahtzee game logic classes. Do 5 more points. So you get the points for doing it, and then you get points for testing it that it did it correctly. right? So if I have a 1, a 2, a 3, a 4, and a 6, there is no points for large straight. There's points for small straight. So you need to make sure that you are correctly scoring each of those 13 categories for a given set of dice. That yes, you can get the score, and also you should get zeros when you should get zeros. So like 2 tests for each one of those. Right? So when you have ones, you score the ones or 0. Right? That one's maybe not quite as complicated, but for 3 of a kind, if you don't have a 3 of a kind, you get 0. If you do have a 3 of a kind, it's the sum of the dice. So up to you on how you want to try and design those tests for the logic there. Okay, so that's the big one, is the scorecard. For dice and rolling dice, we can check to make sure that we roll the correct dice. Now, testing random numbers is hard because we don't really have a way to control random numbers. So I can't say, hey, when I roll the dice, did I get 5 random numbers? It doesn't really work like that. So don't worry about testing, did I get random numbers? There's things we can do once we talk about interfaces later. I'll show you how we can test for that sort of thing. And there's some cool things we can do we'll look at next week that are a little bit above and beyond what we want to do here. So object-oriented design, our correct Yahtzee game logic, our unit tests for the Yahtzee game logic classes, and no, so the next project after this, so after this one is in February 2nd, we'll do a different project, a different game. Yeah. But if you have good object-oriented design here, the idea is that those same business logic classes we can use somewhere else. So another cool thing you can do in C# is you can write web applications in C#. We're not getting into it. We just don't have time in this class, unfortunately, to get into the web stuff. There's a whole other web application class you can take, but you could take that same business logic and just put a web UI on top of it rather than a Windows Form UI on top of it. Or we could do like a Maui project and have a mobile application and say, hey, I'm going to put a mobile UI on top of these classes. So that's why we want the logic to be separate from the UI. That's what our good design does for us here. Yeah, we'll have a quiz over classes, some of the basics of classes, due next Thursday. Thank you, Edward. Yep, I got to post that after class here. So that's 15 points. I wanted some more points. Why am I not coming up with the right number here? That's fine. So let's up this here. We'll do 10 points here for your design. So 10 points for just having the separate business logic from UI. 5 points for it actually working, and then 5 more points for testing that it does work. Okay, that sound reasonable? Yeah. So we got through essentially chapter. We skipped over a couple of them though. Let me double check here. So we did classes, information hiding, properties. So we did like 18, 19, 20. We can come back for enumerations and tuples next week. So yeah, mostly this is on classes and testing. So a couple questions on testing, just from stuff that we've talked about today. This idea that code coverage is important, 100% is a good goal. Any code worth writing is worth testing, those sorts of things. So if you're not sure, shoot me a message, ask about it. But it should all be stuff that I said or stuff out of the text there when it comes to writing our classes. Okay, so I'll make the rubric. So that should be attached for you here. So we've got project 2 to work on for 2 weeks. Yep, so to make a test, so let me look at rectangle. You come to the class here and you right click on it and you say create test. Yep, so if you have a class like a Yahtzee scorecard, then you just go to that class and you make your tests. Yep, so you'll arrange, you'll act, you'll assert. So like when we're arranging our scorecard, we'll say, hey, here's the 5 dice I have, or make an instance of Yahtzee dice if you want to have a class for that, or however you're handling that sort of thing is fine. And then if I give it to the Yahtzee scorecard, what do I get back out? What scores do I get? I expected to get a 25 for my full house because I had a 2 of a kind and a 3 of a kind. Great. That's all fine. So let me give you the other Yahtzee link here as well. So I'm sorry, so there's a couple extra things here that we don't need to worry about here because they make things a little bit more complex here. So don't worry about the Yahtzee bonus and Joker rule. So please ignore the Yahtzee bonus and Joker rule. So in the actual game, if you get more than 1 Yahtzee, which is a 5 of a kind, you can get extra bonus special stuff. Forget it. It's not worth it here. Don't worry about it. Okay, it's not important enough here. This is plenty for for what we need to do here to figure this out. Okay. So, and it's a pretty interesting how well you score these things and probabilities and stuff. Yahtzee is a really interesting game. There's a lot to it here. Yeah, so each class would usually get its own test file. So this is the cups test file. So if I make a rectangle test here as well, if I go to test for rectangle, go create unit tests, we'll make them here. It'll just add a rectangle tests in this test project. Yep, that random function was you make an instance of the random class here, and then you use random.next. And remember, it is not inclusive of the upper bound here. So we can put in a note here. Next is not inclusive of the upper bound. So really I'm getting bound. I'm getting 1 to 99 here. 1 to 99 effectively. So, if you do random 1 to 6, you're not going to get a 6, right, for rolling a die. So keep that in mind. Yep, you give it a range. Yep, upper and lower. Yep, fantastic. So, yeah, ignore the Yahtzee bonus rules, 2-player Yahtzee. Other fun things you can do, just stretch goals for fun if you want. This really could be N players if you want. It doesn't have to just be 2 players. And then you can just show 1 player at a time. That's an option. That's sort of fun, like how many people are playing, and then you just show the 1 scorecard. There's ways to programmatically add some of this stuff. I think we mentioned that a little bit, like what's happening in this designer view here, this designer CS. You can do this stuff in code and say, hey, let me go add a bunch of labels and add a bunch of stuff. That gets a little complex and really above and beyond what we want to tackle for our third class, getting into C# here. So if you want to try it, go for it. It's very fun, but nothing that we need to do at the moment here. So this is just, that was above and beyond what we wanted here. And pictures are fun. There's ways you can generate images and then you set images. We haven't gotten into that yet. That's okay. For now, just labels are fine. And just put the number 1 in text on the screen rather than showing a picture. But, adding pictures later is something that's fun that we can do. So the next project we do in 2 more weeks, we'll start tackling some pictures and having a little more fun with it. But then get a little more experience under our belt first. Okay, let me go save all these things here and make sure we're good. Okay, go commit this. So tests, commit and push. So we got all this out here. Yeah, so range would be 1 to 7. Yep, because that way you can't get the 7, but you can get 1 to 6. So because the range stops at that max number. Yep, and as you play with it, you'll see that you won't get the right numbers if you don't do it right. So should be a little bit of fun here. Okay, awesome. Why did my rubric go away again? I want to see the rubric. That's fine. That's all right. All right, so just a chance to practice more of this stuff, build out some classes, have the classes interact with each other, write some tests to make sure that it does what it's supposed to do, and we can go from there, okay? All right, hopefully you have some fun with it. If you've never played Yahtzee before, it's an entertaining enough game. It's sort of interesting. It's something to do here. Probably a button for each Mo is that, a button to score 1s or a button to score 2s or a button to score 3s, a button to score 4s, and that sort of thing. If they each have a button, that's when you can go and turn them on and off. You can say, okay, hey, once I clicked that button, now it's enabled or disabled, right? So once I've scored 1s, I can turn off the button for score 1s, and then you just can't score it, right? That sort of thing. So you can take advantage of these buttons being enabled and disabled properties as you go. Yep. And again, make your UI as pretty as you want it to be. I don't really care about pretty as long as it is functional. That's okay. And what's really fun about this is that everyone's going to design it just a little bit differently. And that's okay. And you're welcome to talk about your design. If you want to post screenshots of it in Discord, that's fine too. That's just showing some pictures of the layout. That's perfectly fine. I prefer you not to share the code, though. So unless you're working with your partner, that sort of thing. So go through and have some fun playing with this and figure out how you score these things. And in 2 weeks from now, I can build this thing in about an hour for what it's worth. I've done it before, so I don't deserve a whole lot of credit there. But the color of a button, I'm sure you can. I don't know what it is though. I would just go look it up somewhere. So I don't know. Let's just C#, change color of button, Windows form, right? Yeah, here you go. Okay, so it's the back color, looks like, of a button. You can change the back color. And if you can set a property of it, you can also change it in code programmatically. So if you go look at, what is that called? Back color? Back color, if you wanted to change that to, I don't know, something else. Hot track, look at that, hot track. I don't know what that is, but sure, if we take a look at the design view now, we can go see where that button is. Hot track, what was that? Here it is. So you'd say, hey, the back color property is system colors hot track. Sure, why not? Right, or anything we want to do here. So we can change that color to something else. So let's go see. Let's take this line, put it in our form, and then how about when we drink the coffee, we'll say system colors dot. Do we have red? Drawing dot color dot red. There we go, red. We'll set it to red if you can't do anything like that. So make a coffee, drink the coffee. Oh goodness! Oh, I forgot my numbers. Yeah, I mean, you're welcome to have some fun with it here. Okay, so let me do a really big number. There we go, and it turned red. Look at that. We changed the color of our coffee, our button. That was fun. Oh, it stays red. I guess we should put it back here. I don't actually know what the default was. What was the default? System colors normal or something, or active? I don't know. Goodness, what was the default color on a button? Let's go back to the form view and see what is back color was. Control. Okay, back to control dot control. There we go. Set it to a normal color to start. Okay, so we'll make our coffee one. Okay, there's the normal color. Go too large, goes red. Put it back, goes back to normal. So yeah, you can have fun. Yeah, so you can have buttons for set aside. Checkboxes work really well for that. I don't think we talked a whole lot about checkboxes. We did radio buttons, but in your form view, is my not that one. This one here. Form. Oh come on, come on. I didn't break it, did I? Did I really break it? I thought it was running. Yeah, that's fine. Come on. Form. Okay, now it's loading the designer. You can have a checkbox in here, and your checkbox could be checked or unchecked. Right? Same idea with the radio button. You can check if it's checked or not. So you can say, hey, this is for, hold die one or something, sure. And then you can see if this one is held or not. Hold die one checkbox, that sort of thing. And then in your code, right, you can say if it's checked or not, go do something when you click a roll box or something. So you got lots of choices on how you want to do it here. Checkboxes are easy. Making buttons is a little trickier, maybe. It's doable. I don't know, whatever makes more sense to you. Definitely lots of ways to go about it here, for sure. So hopefully you'll have a little bit of fun with this, building out the game, and then it's something you can do afterwards. It's not just a nonsense project where like you're making a fake point of sale system that's not interesting at all. So it actually playing a working game for us is kind of fun. And that's sort of the goal. Right? So if you got questions or concerns, let me know. Again, happy to talk design sort of things in Discord publicly. You're welcome to ask me directly as well, but that sort of thing's great. If you'd like to work with a partner, have at it. If you want to do it solo, have at it. Totally up to you at this point. The final project, though, will be a mandatory group. So you will work with a person. Usually 3s or 4s for the final project. 5 is just too much. 4s is my ideal group. The 3s are pretty good too, though, when it comes to that. But you folks are pretty good. We don't usually have as much dropping at this level, but if you have 3 people and one of them drops, then it kind of sucks to just have a partner. So it's all doable. But here, let me go add in. So this was playing with colors here. And just fun stuff that you can do with it if you want. Have some fun with it, and we can go from there, okay? All right, folks. So if you got anything else, let me know. Shoot me messages. Happy to hop on Zoom calls or Discord or anything. We use some screen shares if you want to chat about stuff. Just let me know. But I think we can call it a day. I can end the stream. And I will see you next week. Hopefully I'll be feeling better. So that's the goal. The cold beds are good. They just make me real loopy. So yeah, thanks so much. Thanks for hanging out in chat. And we can go from there. Look at that. I think I have an ending screen I can even put on here. I'll play us out with some music. Pretend like a screen. if anyone else is. We'll go raid. Yeah, we'll go raid mine. All part of the outer raid. Oh, why not? There we go. We'll get back to you. If just for fun, if you want to join along in the food trade, that's fun. Dr. Hermit's a real nice guy. Positivity out there. So, yeah, see folks around.